Hello everyone. So let's start solving today's problem, largest prime number factor. So in this problem, we have to find out the largest prime factor of a given number. So for example, if the given number is 24, the prime factors of 24 are 2 and 3, and the rest of the factors are composite. So the maximum of these two prime factors is 3. So we simply return this 3 as our answer. And in case of prime number like 5, we don't have any prime factor other than the number itself. So it is 5. Okay. So the approach I'll be following is there's a theorem which says that for a composite number n, the prime factor exists till square root n. So if you consider the example of 24, it is a composite number and the prime factor for 24 exists till 4. Since square root of 24 is nothing but 4.89, which is approximately in integer, it is 4. So as you can see, we've just found out that prime factor of 24 is 3 and 3 is clearly less than 4. So this theorem is valid. Okay, so now let's discuss the approach of this problem. So what I'll be doing is I will simply putting the condition here. I'll be taking my iteration variable, which will be initialized from the very smallest prime number, which is 2, and I'll check if my I square is less than equal to n. Since I should be less than equal to square root n, I'll simply taking the square and it becomes I square is less than equal to n. Now what I'll be doing is I'll be start removing all the prime factors one by one. Okay, so for example, if my n modulo I is 0, so if this condition is satisfied, I will simply remove this prime factor from my number. So n divided by I. Okay. So let me try run this. So let's take n equal to 24 and initially we have I equals to 2. So we check if our while 4 is less than equal to 24. So yes, this condition is satisfied. And if my 24 is divisible by 2, if this is the case. So what I'll be doing is I will simply eliminating the factor of 2 from my 24. Okay. So it will become 12, right? Again, and in case we don't have any factors of 2 in my number, I will simply increment my answer because there might be other prime numbers, right? For example, 3. So we will look at it in the next iteration. So after dividing, we have 12. Now we check while again we have the iteration while 4 is less than equals to 12. Yes, our 4 is less than 12. Then we check that if our 12 is divisible by, so we try to remove the factor of 2 from our 12 now. So if 12 is divisible by 2, yes, it is so. So what we'll do now, n our n becomes 6. Okay. Now again, on the third iteration, we again check if our 4 is less than equal to 6. Yes, this condition is satisfied, but and here what we'll check if our 6 is divisible by 2. Now again we remove the factor of 2 from the 6. So the n becomes 3. Now in this case, the while loop condition gets invalid since 4 is not less than equal to 3, right? So in this case, what we'll do, we were checking that if 3 modulo 2 is 0, so this is not the case, right? So what we'll do in the, so since this while loop condition is invalid, we don't execute this if and else, and we simply return our n. So we have our n as 3. Now let's consider the second test case in which we have n equals to 5. Now you will have bit of a problem when your if condition won't get executed. So we'll start off with 2, the very small prime number, smallest prime number, and we check if our 4 is less than equal to 5, right? And we check if 5 modulo 2 is 0. So this is not valid. This is incorrect. So in the else part, what we'll do, we'll simply increment our answer, which means iteration variable. Now, so the 2 now becomes 3. Then again, we check if 3 square, which is 9, is less than equal to 5. So this condition is invalid, right? So we simply return n, which is nothing but 5. So I have to get the idea what we are doing here. If you didn't get it, still we have the code here. So we will go till the square root of n, and we start off with the smallest prime number, and we check if we can, here we are checking if we can remove factor of prime. Okay, here we are checking if we can remove any prime factor from our number. So we will simply remove it. Otherwise, in case of prime number, we were not able to do it, so we simply increment our answer. And if this condition gets invalid, means if we don't enter while loop, we'll simply return n. So if you still don't get it, you should try it using pen and paper. I'm pretty sure you will get it. All right, thank you.